Talking about artificial intelligence. Um, if we're gonna talk about this stuff, we might as well hit the artificial intelligence. I just watching a video talking about how was it Amazon or Google? I think it was Google is capturing people's voice messages and they're storing them on the cloud. And of course, the question has to come up: why would you do this? What is it that you're going to use this for? And there's no answers to any of these questions. So let's go ahead and get started. A lot of strange stuff going on right now with AI. One of the things that is happening is that the federal government is putting what $150 billion into investigating AI technology. So they're going to be using it, or at least that's what they're talking about. Of course, with this administration, one of they seem to be partnered with not only Mark Zuckerberg from Facebook, but also the owner of Google, Jeff Bezos, and especially Elon Musk, who controls X, or what used to be Twitter. Now it's X. So let's go ahead and get started. We'll start talking about this. All the information that I have. This is from a text. This is from a book. Oh, this is from this book. The Myth of Artificial Intelligence: Why Computers Can't Think the Way That We Do, by Eric Larson. Larson is one of the premier um, philosophers, investigators of the concept of artificial intelligence. And of course, the book was written. When was the book written? 2021, and it's already outdated. So much has happened. With Siri and with what is it, Alexa. Which one of those is stealing people's voice messages? I think it's Alexa, if I'm not mistaken. But you have to sign up for it. I don't know why you would. So let's go ahead and get started and start talking about artificial intelligence. And there's a reason why I do not want you to use ChatGPT in with your papers. If ChatGPT can write you your paper if you want. Grammatically, it's fine, but it doesn't have any of your own thoughts, and that's the reason I don't want people using ChatGPT. The science people, that they don't mind because they think this is the new wave of the future. We're not going to have to figure this out anymore. Any scientific breakthroughs, it's all going to come from AI. But in psychology, that's not the way it works, since AI can't think like humans. One of the problems that they've had with chatbots is that chatbots get really nasty pretty quick. They get angry. They start talking about sexual things, and then they just kind of guide you in, or they think that you're guiding them into that direction, but the reality is, of course, that is programmed in to their response. So let's go ahead and get started. The Myth of Artificial Intelligence by Eric Larson. There you go. E.J. Larson, 2021, The Myth of Artificial Intelligence. Why Computers Can't Think the Way That We Do. It's from Harvard University Press. I just showed you the book. It's, how many pages? About 300 pages. The story of artificial intelligence starts with computer pioneer Alan Turing, who published a paper on the topic in 1950. Turing proposed to test a computer's intelligence by having a computer and human perform the same task. The task will then be judged by a group of judges, and if the majority of the judges can accurately identify which is the computer and which is the human, the computer will win. And this is known as the Turing test. And he came up with it in 1950. So we've been using this to judge how strong artificial intelligence is since 1950. At Bletchley Park during World War II, England's most progressive thinkers came together to break German and Japanese communication codes. Guessing is known in science as forming hypotheses, and it is absolutely fundamental to the advancement of human knowledge. The Bletchley effort amounted to a system of guessing well. Intelligence is situational. There is no such thing as general intelligence. Your brain is one piece in a broader system which includes your body, your environment, other humans, and culture as a whole. Intelligence is contextual. Far from existing in a vacuum, any individual intelligence will always be both defined and limited by its environment. Human intelligence is largely externalized. It's contained not in your brain, but in your civilization. Our brains are modules in a cognitive system much larger than ourselves. Can intuition be programmed? The idea of programming intuition ignores the fundamental fact about our own smarts. Humans have social intelligence. We have emotional intelligence. We use our minds other than to solve problems and puzzles. Sorry, I needed a drink. The problem-solving view of intelligence helps explain the production of invariably narrow applications of AI throughout its history. Game playing has been a source of constant inspiration for a development of advanced AI techniques, but games are simplifications of life that reward simplified views of intelligence. A chess program plays chess, but does rather poorly driving a car. So you can create a robot that actually plays chess, but that robot will not be able to drive your car. Treating intelligence as problem solving gives us narrow application. If machines could learn to become general, we would witness a smooth transition from specific applications to general thinking beings. We would have AI. To accomplish their goals, what is now called machine learning systems must each learn something specific. Researchers call this giving machines a bias. Researchers have realized that giving a machine learning system a bias to learn a particular application or task means it will do more poorly on other tasks. There is an inverse correlation between a machine's success in learning some thing and its success in learning some other things. Machine learning bias is typically understood as a source of learning error, a technical problem. Machine learning bias can introduce error simply because the system doesn't look for certain solutions in the first place. But bias is actually necessary in machine learning. It's part of learning itself. Things occur to us, we reason through our observations and what we already know. Answers pop into our heads. All of this buzz of biological magic remains opaque. It's processing, still uncharted. And, this is the trillions of connectors that we have in our brain. That's how we figure things out. Machines tasked with designing new and better machines face a fundamental stumbling block. Any design for a new machine must be specified in the parent machine. The parent machine would necessarily be more complex, not less, than its creation. An organization which synthesizes something is necessarily more complicated, of a higher order than the organization that it synthesizes. What does that mean? So the more intelligent the computer, that's the limit, whatever its intelligence level is. It cannot create a computer It cannot create an AI or a robot that is more intelligent than it is. Inference is to bring about a new thought which in logic amounts to drawing a conclusion, and more generally involves using what we already know and what we see or observe to update prior beliefs. Inference is a basic cognitive act for intelligent minds. If an AI system is not inferring at all, it doesn't really deserve to be called artificial intelligence or AI. We know a lot of things, but only inference gets us to new knowledge. Real world circumstances are always changing, so real world inference is common and necessary, just like the tariffs that went in yesterday. This is all brand new stuff, and artificial intelligence can't figure out the formula that was used to create these ideas of tariffs, of how in the world did they come up with their figures. The ability to determine which bits of knowledge are relevant is not a computational skill. Human insights are not arrived at by formula. Scientists frame hypotheses, then test them. But the hypotheses aren't arrived at mechanically. They sometimes just pop into scientists' heads, typically after mastery of the field, and it blows their mind with purple smoke. Copernicus posited that the Earth revolved around the sun. He made a conjecture that went against all previous knowledge. The fact that conjectures lead to discoveries doesn't fit with mechanical accounts of science. It contradicts them. But detective work, scientific discovery, innovation, and common sense are all workings of the mind. They are inferences that AI scientists in search of generally intelligent machines must somehow account for. Deductive reasoning is a logical approach where you progress from general ideas to specific conclusions. The problem with deductive reasoning is that it never adds knowledge. Deduction is useless in the pursuit of knowledge, and it only clears up disputed beliefs if bona fide errors in reasoning are made. Conspiracy theorists might never make deductive reasoning mistakes. It's just that they adopt premises as true that others find dubious or just crazy, like Copernicus. Copernicus is the only one that is the individual that came up with the idea that the planets were rotating around the sun. He came up with that. Everyone else was thinking, including the religious leaders, that everything was rotated around the Earth. Now, because Copernicus came up with a new idea, he was shunned, and it's because the deductive reasoning told everybody that this was not the way it was supposed to be. This was not the way it was. Copernicus came up with the idea, and of course he not only was told that he was wrong by all the scientists of the era, but he was also told that he was wrong by by the religious leaders, and of course religion trumped just about everything else in that point in time. Induction means acquiring knowledge from experience. Induction captures the everyday idea that we gain the ability to explain and predict by observing happenings in the world. Modern AI is based on statistical analysis and so relies on an inductive framework, which is useful for many commercial applications. AI can offer recommendations, a type of prediction based on past observations. At its root, all inductions are based on enumeration. Machine learning can never supply real understanding because the analysis of data does not bridge to knowledge of the causal structure of the real world essential for intelligence. The ladder of causation steps up from associating data points, seeing and observing, to intervening in the world, doing, which requires knowledge of causes. Then it moves to counterfactual thinking like imagining, understanding, and asking, what if I had done something different? A good example of this would be the self-driving car. They're trying to develop a self-driving car, um, and they can't. It just isn't working. It runs over people. It wrecks into other cars. They tried to drive one down a winding um, rural road, and it worked. It was able to do it, but there was nothing in its way. It didn't have to stop for livestock. It didn't have to stop for a deer. You know, a skunk didn't run across the road. All of these things. All of these things are things that a human would respond to that AI potentially can't, unless it is programmed into it that if a black and white um, animal the size of a cat tries to run across the road, you need to hit the brakes. Common sense is what enables two people to engage in ordinary conversation. The problem of common sense, and in particular language understanding, which requires it, has been a signal concern among AI researchers since the field's inception. Common sense. Machine learning is getting computers to improve their performance based on experience. There are two types of learning. Supervised learning, that is identified information that leads to a desired outcome, and unsupervised learning, where masses of data is analyzed to determine a pattern of information. Early AI scientists assumed many problems in the real world could be solved by supplying rules amounting to functions with known outputs, as with addition, like 2 plus 2 equals 4. It turned out that most problems that count as interesting to AI researchers have unknown functions. Hence, we now have machine learning, which seeks to approximate or simulate these unknowns. This fakeness of machine learning goes unnoticed when system performance is notably close to a human's or better. But the simulative nature of machine learning gets exposed quickly when the real world departs from the learned simulation. And that's the biggest problem, is the fact that as long as it's been programmed into the computer can respond. 1 plus 1 0, 1, 0, 1, 1, 1, 0, 0, 0. Those kinds of reactions can take place. But if it has to figure something out, if it's something that isn't programmed into it, it can't do it. It can't function because it's not programmed in there. Remember, a computer, like any machine, like you can't get your microwave to turn on your television set. Well, I guess you can, but you have to program it in. Everything has to be programmed in, just like you do with Alexa or whatever. If you tell it to do something that is not in its program, it can't do it. The limits of a machine learning system's world are precisely established by the data set given to it in its training. So the guy that programmed your robot or your computer, they're the ones that told it what it can do. If it wasn't told what it could do, if it wasn't told something that you want it to do, then it can't do it. Any given data set is only a very small time slice representing partial evidence of the behavior of real-world systems. A trained system can predict outcomes, seemingly understanding a problem until an unexpected change or event renders the simulation worthless. Simulations that fail can be worse than worthless, as with a robot car or at automated prediction that instills false confidence. And that's part of the problem. If people think that AI is infallible, then they're going to accept everything that they say. Well, the next thing that may happen is that if you're flying to Mars, you might miss it by, a couple of 100,000 miles or something. The most powerful learning systems are much more narrow and brittle than we might suppose because the systems are just simulations. All the problems of induction bedevil machine learning and data-centric approaches to AI. Data are just approved facts stored in computers for accessibility. And observed facts don't get us to general understanding of intelligence. Big data is an inevitable consequence as computers become more powerful, statistical techniques like machine learning become better, and new business models emerge, all from data and its analysis. What we now refer to as data science is really an old field given new wings and massive volumes of data, mostly made available by the growth of the web. Now you got to remember that I've been in education for a long time. I started going to school in 1954. Is that right? Yeah, I started going to school in 1954. Computers were the World Wide Web was invented in 1993. So I've been watching this as it has accumulated. Memory, for example, I can, uh, if you have any history with computers, then you remember that, CD-ROMs. You remember jump drives that could only hold, 573 kilobytes. Now it's terabytes. Now you're talking about terabytes. But then you could only put so much on a jump drive. As a matter of fact, I have old jump drives here that have hardly anything on them. You couldn't put pictures because pictures were too large. You certainly couldn't put videos on anything. But now, of course, as memory increases, and this is data, this is what we're talking about. We're talking about data. As data increases and as we start accumulating more and more data and expanding our memory in our computers, now all of a sudden we can process a lot more information. Does that help us? Well, that's one of the databases that the library has. That's how they function. Is they have all of this information, and you buy the database. The database has, like the site database, has all the journal articles from psychology. I'm sure business has the same thing, and so does public health, and so does the sciences. And this is all big data. And of course, we're thinking, oh, we're expanding knowledge. Are we really expanding knowledge is the question. The, or are we just accumulating new information that AI has the ability to tap into? The focus on deep learning makes sense. The algorithms, rather than the data, are responsible for trouncing human champions at Go, mastering Atari games, driving cars, and the rest of the AI successes. Big data has found a home in AI, as data-driven approaches like machine learning all benefit from huge volumes of data from training models and testing them. As one observer put it recently, big data has become big data AI. Machine learning systems are sophisticated counting machines. The frequency assumption comes into play because the greater the frequency of hits on a feature, the more useful it is. Sarcasm is particularly opaque to machine learning, in part because it's less frequent than literal meaning. Counting turns out to work well for certain obvious tasks online, but works against more subtle ones. Sarcasm isn't a word-based feature, and neither is it as frequent as literal meaning. Machine learning is notoriously obtuse about such language phenomenon. And this is a problem. It doesn't recognize sarcasm. And this is a joke on Big Bang Theory because not Leonard, what's the other guy? Sheldon. Sheldon couldn't understand sarcasm. So people would tease him and they would say something sarcastic and he wouldn't get it. And computers are the same way. Computers don't understand sarcasm because they can't understand language skills like this. It's wordplay. Saturation occurs when adding more data, more examples to a learning algorithm or a statistical technique adds nothing to the performance of the system. When we seek to understand particular facts rather than regularities, we are forced into a kind of conjuring, the selection or invention of a hypothesis that might explain the fact. Induction moves from facts to generalizations that give us knowledge of regularity. But abduction moves from observation of a particular fact to a rule of hypothesis that explains it. Abduction is tied closely to reasoning from events to their causes. Abduction captures the insight that much of everyday reasoning is a kind of detective work where facts or data as clues are seen to help make sense of things that we're thinking about, things that we're questions that we're asking. Humans are extraordinarily good at hypothesizing, which is not explainable by mechanics but by an operation described as instinct. Guessing from infinite possibilities, the most plausible hypotheses is selected. These factors must be included in developing AI. Without an abduction step, inductions are blind and deductions are useless. If deduction is inadequate and induction is inadequate, then there must be a theory of abduction. Since there is no theory, it can be concluded that there is yet to be a path to artificial general intelligence. Causal information about the world cannot be extracted from associations in data, so explanations involving why or how questions can't even be formulated, let alone answered. Causal knowledge forms part of the common sense understanding of the world and explains why data as effects or clues to prior causes that contribute to understanding can be seen. We're looking for causal knowledge. What causes this? Why does this happen? We're looking, we're trying to figure out why somebody is sick. This doesn't make any sense. We can't find a cause. We need to find a bacteria, a virus, a fungus, a poison, a toxin. Something has made this person sick, and we need to figure out why. We can figure that out because we're human and we have the ability to deduce. But can AI do that? Can AI move from common sense to common sense? And the answer is no, it can't. It can only do what it's programmed to do. And if that information doesn't exist, then it can't create new information. Imagination involves inferences that don't exist in a database. Imagining requires conjecture, if anything does. Abduction is inference that sits in the center of all intelligence. Most of what is known is implicit. Knowledge is brought into consciousness, making it explicit, only when circumstances require it, like when someone is surprised or has to think through something deliberately. All implicit knowledge might be necessary for some inference or other, but the total amount is vast. The knowledge base of an ordinary person is unbelievably large, and inputting and representing it in a computer is a gargantuan task. Implicit knowledge. This is any common individual. Their brain structure is so much more vast than you can create, and you can't create a computer that has that knowledge base. Abduction gets harder and harder. It soon departs from known conceptions of automatic inference or computations. Take scientific discovery or innovation. Human beings invent languages, concepts, and laws to explain the world. This is creative abduction. Creative abductions leap to novel conceptual frameworks themselves. Mysterious and wonderful abductive inferences pervade human culture. They are largely what makes us human. All roads lead here. AI lacks a fundamental theory, a theory of abductive inference. The problem is that little of everyday world is captured by timeless truths, and even when there is certainty, Deductive inference ignores considerations of relevance. Inductive inference provides provisional knowledge because the future might not resemble the past, and it won't. And that's why a computer can't figure it out, because it can only see what it has been programmed to see. And that's the past. It can't see anything in the future. It can't even see anything in the present, not if it has changed. Intelligent thought involves knowledge that outstrips what can be bluntly observed, but it's a mystery how knowledge is acquired and how the right knowledge is applied to a problem at the right time. Neither deduction or induction illuminates this core mystery of human intelligence. The abductive inference that was proposed long ago does not, no one knows how to program it. We can't program abductive inference. In pragmatics, what is said is tightly dependent on how it is said and why it is said. What people mean is almost never a literal function of what they word for word say. This feature of ordinary talk studied in linguistics as pragmatics is what makes language interpretation hard for artificial intelligence, but meaningful, interesting, and generally easy and natural for people. And this is the idioms that we talk so much about. And for a lot of people, the reason that the English language is so difficult is because of our idioms, the things that don't make any sense. Bring home the bacon. Oh, bring home the bacon. Yeah, we have a lot of idioms, and especially in English, and they just don't make sense to people who are not from the United States. Even English people from England can't understand our idioms. Prose showcases the ubiquity of pragmatic phenomena in language in nearly every ordinary sentence. It's inescapable. Deixis refers to words like pronouns that cannot be understood or disambiguated without knowledge of context. Excuse my knowledge. Knowledge of context. Let me take a drink, okay? Deixis refers to words like pronouns that cannot be understood or disambiguated without knowledge of context, like me or he or here. Deixis means pointing, and language often points, and this is understood by the listener in context. A system engaged in a conversation but not resorting to cant tricks must keep track of everything. It must keep track of what you're talking about and who you're talking to. And this just happened with Donald Trump. Trump told a story about General Kane. He's the new head of the Joint Chiefs of Staff, and he said that Trump said, well, the first time I met him was in Iraq, and we shook hands, and he said, "I love you, sir. I will kill for you, sir." And then he put on a MAGA hat. Now who said this to him? Was it Kane that said this to him, or was it somebody else? He didn't say it was Kane that actually put on the MAGA hat, which is against military rules. So it was very confusing. The question is, who was he talking about? Who was he pointing to? Was he pointing at a sergeant that was standing beside the general, or was he talking about Kane, who was at the time, I think he was a 3-star general, and should have known better than to put on anything political. It's not allowed in the military. You can't wear buttons that say I'm a Democrat or I'm a Republican. You can't do that. It's against military regulations. It's against the UCMJ. In the early part of the 20th century, the philosopher of language Paul Grice offered maxims for successful conversation. The maxim of quantity. Try to be as informative as possible and give as much information as is needed, but no more. The maxim of quality. Try to be truthful and don't give information that is false or that is not supported by evidence. The maxim of relation. Try to be relevant and say things that are pertinent to the discussion. The maxim of manner. Try to be as clear, as brief, and as orderly as you can and avoid obscurity and ambiguity. In 2004 at IBM Research, the head researcher said, "We're going to make history. Money isn't an object. Find a way to build a system that plays Jeopardy!" The television show. IBM assembled a team of top talent and spent the next 3 years doing due diligence on the requirements for a question, answering a system capable of playing world-class Jeopardy! The magical quality of IBM's Watson system is its search for answers. Fully 95% of all answers to Jeopardy! Questions that are just Wikipedia titles. This serendipitous discovery made the entire effort possible. Simply matching questions to Wikipedia titles would by itself result in superhuman level gameplay. As usual, the devil is in the details. Watson crushed Jeopardy! But had no other function. Watson proved once and for all that all successful AI is narrow. Watson is not a step toward general intelligence, but rather further evidence that the quest for generality remains mired in mystery and confusion. While the IBM team did score an impressive victory using a powerful hybrid system, it did not discover a key to language understanding. All the problems of programming abduction inferences for general intelligence remains. It could not do it. The only thing that Watson could do is answer Jeopardy! Questions. And what did it do? All it used was Wikipedia titles. That's it. So what is its function? It has no function. Yes, it can play Jeopardy! And that's it. Every reasoning machine has had two inherent impotencies. It is destitute of all originality and initiative. It cannot find its own problems. It cannot feed itself. It cannot direct itself between different possible procedures. The capacity of a machine has absolute limitations. It has been contrived to do a certain thing, and it can do nothing else. In 2005, there was a blogger revolution to make the internet as free as possible. Web denizens were poised to rewrite the rule books, ridding the world of stodgy gatekeepers like mainstream press and media who unfairly controlled the production and flow of news and knowledge. Power to the people was the trope of the mid-2000s, spread endlessly in blogs, commentary, and online collaboration of hive mentality. Instead, the billionaires took over and made more money. The human brain has more than 100 trillion neuronal synapses. So a computer recording a simple binary piece of information about synapses would require 100 terabytes. The amount of storage needed to store even this simple information every second over the course of a day for one person would be more than 100,000 terabytes, or 100 petabytes. Supercomputers hold about 10 petabytes. This quick calculation doesn't account for the changes in connectivity and positions of synapses over time. Counting how these connections change just after a good night's sleep or a class in mathematics amounts to a whopping figure. And it's impossible. Everything in your brain is so much more sophisticated than even the most sophisticated computer system. Even masses of computers, it's still stronger than that. And this is one of the reasons that cryptocurrency is it's going to burn up a lot of energy. Just maintaining all of that money is going to take masses and masses of energy. Attempts have been made to promote abductive reasoning in computers. While representing an advance in applying machine learning to biological data sets, the approach has an average error rate of 2 in 10. This has ominous implications for any strategy for reverse engineering the human brain. It is the shallow logic behind such approaches that spell deeper trouble for the institution of science. And this is why, no matter how badly you drive your car, you drive it better than artificial intelligence would, or as it has been able to do up to this point. AI and big data works only when we have prior theory. A great deal of confusion and potential trouble for science lies precisely with this point. Neuroscience, unlike particle physics, has no unifying theoretical framework. This is a problem, and this is a problem. My son works in cybersecurity for the government, and one of the problems is that there are no basic structures that they can use. Every time a hacker starts using a different program, they have to figure out how to block that hacker and punish him. Usually, they try to punish him in some way by destroying his computer or whatever. But hackers come up with new programs, new plans for getting into things, to use flaws in the system. And my son is able to, because of his mathematics background and because of his computer systems background, he's able to recognize the language that is being used, and he's able to reprogram the algorithm that is being used to hack into the system. He's pretty good at it, and and when he started working there, he had just gotten out of he just finished a master's degree, and he has two master's degrees. One's in data systems, and the other's in theoretical mathematics. And as soon as he started working with the government, he came up with a new algorithm that actually is able to identify all these things. But of course, it's mechanical. It's mechanical, and he has created it. It's not like it can infer something. It has to be watched all the time in order to see what it has done. In order to get it to stop things. Kind of hard to explain, isn't it, without disclosing too much information. The challenge for neuroscientists is to defend the current data-driven model in the absence of theoretical insights, making sense of and guiding the deluge of data. And that was part of the problem. They were cherry picking the data that they were trying to protect, to see if someone had utilized it in a way that they didn't want. And what he did, he was able to write a program that looked at all the data and found anomalies. So there you go. I mean, he found the anomalies, and so why didn't they do this before? Why weren't they doing this before? And the answer is because they had used, just a random sample before. Well, one of the things that they discovered was that the Chinese had broken into some of the military computers, and so had the Russians, and they had implanted Trojan horses, and they had implanted things in there, and he was able to find all that stuff and pick it out because they were hiding in places that no one usually looked, because they were just cherry picking which data they would protect, and he was able to look at all of it. and especially look at the innocuous information. Anyway, society is about to experience an epidemic of false positives coming out of big data projects. When you have a large amount of data, your appetite for hypotheses tends to be even larger. If it's growing faster than the statistical strength of the data, then many of our influences are likely to be false. They're likely to be white noise. And this is exactly why he was able to find all this stuff. The danger of overfitting theories, models to data, where overfitting here means spuriously matching a set of data points to a description that contains no genuine explanatory power. The description does not generalize to new unseen data points in the underlying distribution in question. There you go. Yeah, let's put the Oscar Mobile in a garage that is too small. How dumb can you be? The simplest case of model of a set of data points is the linear interpolation of a scatter plot. Now, if you look at this, who wouldn't know, who wouldn't understand that your vehicle was too tall to get it into that garage structure? Were they not watching? I mean, you should understand where the top of your vehicle is. We all do. We all do. Why do we? Because we drive that vehicle, all the time. We know exactly how tall it is. We don't think about it. And when we see something that's smaller than that, we know, maybe we shouldn't do that. So why didn't these guys know that? I mean, that was quite a bit. Where in the world were they trying to put it? The simplest case of model of a set of data points is the linear interpolation of a scatter plot. A straight line shows the average interpolation of the scattered data, and as such, gives a useful model predicting the behavior of the data. Overfitting, making the data fit the hypothesis, gives false confidence on existing data, but quickly shatters this illusion when new data arrives that doesn't fit the model or theory. And this is usually what it looks like. When we do in any kind of research, a lot of times this is what we get. I mean, this means nothing because there are no lines. There's no lines of data that say this is, on the average, this is pretty close, but this is all over the map. And the problem is that as scientists, we like to be right. So we try to force the information to fit what we think. And then we get this. And we say, oh, look what we found. New ideas can't be predicted, and thus we should expect the consolidation of the web into big tech will skew work on AI toward narrow applications on the profit curve, while inventions that can never be counted on get short shrift. Over the last year, magazines around the world have discussed the benefits and dangers of AI technology. The May issue of AARP, May of 2023, warns of grandparent scams where AI software synthesizes a grandchild's voice and creates a plea for quick cash in the child's synthesized voice taken from a social media post. This is something that we saw in 2023. Now we know why they're taking our voices, don't we? The June issue of the APA's Monitor on Psychology suggested that psychology professors find a way to teach using ChatGPT, even vaguely suggesting that critical thinking could be supported by helping students think critically about topics they're already familiar with. Like talking with a colleague, it can be an interactive partner. And that was in 2023 as well. And now I won't let you use ChatGPT. Now, why is that? Why is that? Because ChatGPT writes your paper for you. Are you having a conversation with it? No, you just give it little chunks of information and it writes you a paper on that. Is that a conversation between you and ChatGPT as a partner? No. It's not. I'm sorry. Even the Saturday Evening Post has weighed in on the debate of AI and ChatGPT. Altman states that AI has been helping us for decades with computer problems. Clippy, the creepy animated paperclip from an earlier version of Microsoft Word, hovered around and made faces while you typed, was an AI program. And it was really creepy. I don't know if you remember this. It was really strange. It's a paperclip that would walk around your screen and make faces at you. It has been observed that ChatGPT will pick up negative societal biases. For instance, if an algorithm is trying to determine which job candidate is the best fit, it will look at what qualifications correlate with a successful employee. If the company hired mainly non-diverse people, the algorithm will continue to recommend non-diverse candidates. This can have dire consequences when algorithms are assessing creditworthiness for borrowers or recidivism rates for convicts, as well as suitability for employment. How is if all of your employees are white and you have a black candidate, what's the probability it's going to choose the black candidate, even if his information, even if his criteria is so much better than everybody else's, since one of the criteria seems to be that he needs to have white skin. Now you think I'm not being honest here, but this is the way it works. You can program that into your criteria, and it can AI might pick it up subtly. It can do the same thing with age. It can do the same thing with education. I just had this debate with a colleague. They were saying, well, people from Harvard are so much smarter than everybody else, and we should use their education level as criteria. So we should look at what institution they came from. And I said, no, it doesn't have anything to do with it. As long as they have a PhD, there's no reason to even look at that. If AI knows everything about you, it can manipulate you in ways that will make targeted marketing look quaint. And in the universe of fake news, the fakes are going to get a whole lot more realistic and difficult to challenge. Imagine the possibility of creating a fake video showing a politician mouthing words they've never actually spoken or participating in some shameful activity that never actually occurred. That's becoming easier than ever to do. As the saying goes, knowledge is power. Cynical opinion leaders and crooks will certainly use AI to mislead and defraud us. After the June issue of Monitor on Psychology tried to convince psychology professors to embrace the technology, don't get left behind, the July-August issue offered a different take on AI. AI tools used in healthcare have discriminated against people based on their race and disability status. Rogue chatbots have spread misinformation and professed their love for users and sexually harassed minors, which prompted leaders in tech and science to call pause to research in March. What protection could help ensure privacy, transparency, and equity as these tools are increasingly used across society? What is going to protect us? Researchers analyzed interactions at a hotel in Malaysia employing both robots and human workers. After hotel guests interacted with robot workers, they treated the human workers with less respect. There was a spillover effect where suddenly we have these agents that are tools and they can cause us to view humans as tools too. Think about it. In addition to making mental health support more affordable and accessible, chatbots can help people who may shy away from a human therapist, such as those new to therapy or people with social anxiety. They also offer the opportunity for the field to reimagine itself, to intentionally build culturally competent AIs that can make psychology more inclusive. My concern is that AI won't be inclusive. At the end of the day, it has to be trained. Who is programming it? And that is the basic question. And that's one of the questions we have for Elon Musk, who is going through the government and firing people. Who's making these decisions? Turns out that it's a kid that just graduated from high school. It turns out that it's a guy that flunked out of college. These are the people that are making decisions as to who keeps their job and who loses their job. In January, the mental health nonprofit COCO offered counseling to 4,000 people without telling them the support came from ChatGPT 3. Reports have also emerged that getting therapy from generative language models, which produce different text in each interaction, making it difficult to test for clinical validity or safety, has led to suicides and other harms. Before integrating AI tools into their workflow, many clinicians want more information on how patient data are being handled and what apps are safe and ethical to use. The field also needs a better understanding of the error rates and types of errors those tools tend to make. Psychologists have a long measured behavior through self-reports and lab experiments, but they can now use AI to monitor things like social media activity, credit card spending, GPS data, and smartphone metrics. That actually changes a lot because suddenly we can look at individual differences as they play out in everyday behavior. The University of Notre Dame is testing an algorithm that collects screenshots of patients' online activity to flag the use or viewing of terms related to suicide and self-harm. By pairing that data with EMAs, ecological momentary assessments, and psychological metrics from a smartwatch, they hope to build a tool that can alert clinicians in real time about patients' suicide risk. And here is some of the information that I took or I used. There you go. Yeah. Okay. So my point is we need to keep an eye on AI. One of the problems that we have is that sometimes medications are put into the general use and they have problems for select individuals. The same thing is going to happen with AI. Until we see how they interact with everybody, not just some people, sometimes it isn't going to work. Uh, you know, everybody's different. Anyway, okay, so I'll talk to you guys next week.